So I'll start with this. 20-something years ago, I was sitting in our living room, seeing how Arnold Schwarzenegger kicks ass as a Terminator, and as a 6-year-old, wondering, how does one engineer a cyborg? Naturally, the answer came as a 6-year-old, well, it's done by nanotechnologies and quantum physics and mathematics, and because I didn't quite like maths, I went to study nanotechnology. Essentially, if you look at leading scientific journals nowadays, you see that artificial life is coming, it's on its way. And some of you might already be worried that we're coming to the Terminator scenario, that it's not going to end up well for humankind. However, I'll be honest with you, a lot of other scientists also agree that despite the fact that we are going in the right direction, we're not quite there yet. And even if artificial life is going to come, it's most likely going to merge with humanity rather than take it over. Now, if we look at a human being, it's evolved by millions and millions and millions and millions of years of evolution, whereas like some artificial thing, it's going to be made by PhD students and scientists, and hopefully for PhD students it's not going to take a million years to get there. But at this point you might be wondering yourself, what does this cyborgs have to do with nanotech? And what is nanotech? Well, nanotechnology is a study of something that's 1,000,000 times smaller than the smallest unit on your ruler. It's smaller than the wavelength of light. That's how small it is. And if you take Shakir and you put him into a perspective of a virus which has about 10 nanometers, and if you stand in front of a stadium where he likes to play football and put that into the perspective of a red blood cell, well, that's what the comparison is. Just imagine what the difference from if a cell is and what nano is. But let's get back to artificial life, cyborgs, and so on. If we look at them, a cyborg and a normal human being, they look pretty much the same. Well, the cyborg has nice shades and a gun, the other one doesn't. The thing is, if you look a bit closer, you see that normal human beings are made by normal human cells, whereas a cyborg is going to be built out of something that's synthetic, something that's a bit more enhanced. And this is what scientists are trying to do nowadays. They're trying to engineer natural human cells to be a bit more tough. And scientists are lazy in a way that they don't like to start from scratch. They like to combine things from something that's already present and something else that's already present and combine it. And this is where we get to the topic of nanohybrids. Hybrids are well known to humanity since ancient Greece. We have the Minotaur and so on, and nowadays if you take, for example, this guy in a bull and this girl in a fish, naturally you'd get these things. However, these are a bit too big for now. Now, if we want to go to a nanoscale, we want to engineer a cell. And a cell is built out of many things, and as a scientist, PhD students like to focus on a very, very, very specific thing in the whole project. And in our case, we just focus on the membrane. So we try to engineer some synthetic cells, synthetic cell organelles by just engineering, let's say, the membrane and taking all the other useful stuff from natural things. And this we do by synthesizing novel synthetic materials. Our chemists are really good at synthesizing polymers that mimic natural phospholipids. And these synthetic polymers also self-assemble into membranes, like cell membranes. However, the thing is, they don't have any functionality. Cell evolved over millions of years are just polymer, just plastic. Now, our plastic is more durable, more stable, and the thing is, it can be equipped with the exact same molecules that the normal cells have. So all the proteins, all the receptors, all the useful stuff that the cell has in the form of proteins and sugars, we can transfer it to our synthetic materials. And once the cell assembles spontaneously, it also forms some objects in the nanometer scale, so about 100, 200 nanometers big, that represent basically natural cell organelles, but that they're made out of synthetic materials. So if we take like an artificial organelle that we're trying to build, what would we need? You can imagine it like a car. You need first of all the chassis. The chassis is built out of this synthetic polymer. Then you need like a membrane some engine. This we take enzymes that we extract out of cells, and then you need some, again, substrate. The substrates are usually synthetic, and you need some way for the fuel to enter the engine. And these we take membrane proteins that are naturally present in bacteria, and we transfer it into our synthetic material in order for the substrate to reach the engine inside, so the enzymes. And you might be asking yourself, well, actually, hey, they're quite on the way to the Terminator, and this might not look as good. But to tell the truth, these objects are currently being used as novel nanomedicines. So the future isn't so not bright, it's quite bright because it's being used for cancer treatment, it's being used for very specific diagnostic methods as biosensor and as many other environmental applications. So with that, I'd like to thank you for your attention. Yeah, and I hope you have faith in nano and faith in the future of nano.